Welcome to tonight's event. I would like to just see a quick show of hands for how many people have been to a Vancouver Hardware Meetup before. Okay. And how many, is this your first event? It's like always 50-50-ish. It's like pretty impressive. Yeah. Well, thank you for coming to tonight's event. We're very excited to have you. I'd like to start this evening with a land acknowledgement that tonight's event takes place on the unceded ancestral territory of the Coast Salish peoples, the Tsleil-Waututh and Musqueam nations. We do adhere to a code of conduct at our events. We promise a welcoming environment at our events for all, regardless of gender, identity, sexual orientation, disability, appearance, race, age, or religion, and harassment of any kind will not be tolerated. And to let you know a bit about MistyWest, I guess I should also introduce myself since I'm up here. My name is Madison. I am the organizer of Vancouver Hardware Meetup, and I'm also the director of content at MistyWest. MistyWest is a Vancouver-based engineering design consultancy that exists to create an inclusive and prosperous global community enabled by technology. One of our most recent projects is low-volume manufacturing for a commercial LiDAR-based 3D mapping device used for subterranean exploration. And we've also designed polar bear tracking devices and miniaturized muon tomographers that harness cosmic rays from space. And I would just like to give a shout out to our venue, Manning Elliott, and the Manning Elliott team that are here this evening. We are very grateful to them for hosting these events. This is our third event with them, and these always are the smoothest ones that we have ever done. Each one better than the last. Mike, did you want to come up and say a quick word?
Welcome, everyone. My name is Michael Weatherby with Manning Elliott. Full-service accounting firm. We got offices in Abbotsford, South Surrey, Burnaby, and downtown, obviously. I do the R&D advisory, and shameless plug, I think if your companies are growing and you're having trouble with your bookkeeping services, Manning Elliott does the sort of the online pay-as-you-go monthly and bookkeeping stuff. So if anyone has any questions about that or R&D, feel free to come and harass me. I'd love it.
Thank you. And I would also like to give a shout out to our sponsors. With their gracious contributions, these are what make our hardware meetups possible, and their support enables us to continue bringing these events together for years to come. I want to give thanks to Nordic Semiconductor as well as Macaulay Private Wealth. Jameson, are you here? Jameson was coming tonight. Don't see. Not yet. And Hawkridge Systems, I believe we have two people from Hawkridge this evening. Yeah, we have Herman Wong and Jordan Winger. Did you guys want to come up and say a quick word? Sure. It's like the Oscars coming. Yeah.
Thanks. Hey, everybody. Thanks for having us here tonight, MistyWest. And I just wanted to share a quick little note about Hawkridge Systems. Some of you may know us, some of you might not, but we're an engineering partner. We're an engineering solution and software provider, but also we're branching more and more into things like services and mentoring. If you need help with anything as far as, well, our primary software is SolidWorks. You may have heard of SolidWorks, which is a CAD modeling program, but anything in the SolidWorks family, we offer services for that. And we even have a strategic partnership with A3D, which is a manufacturing branch of our company as well. So getting into some manufacturing services as well. So if you want to come see us later on and chat and say hello, we can talk about that. Or if you want to just talk about mountain biking, I'll happy to chat about that too. So thanks for having us.
Thank you. And I'd like to introduce our panelists for this evening. Oh, I forgot to check the last name pronunciation for Suzanne. Is it Gildert? Oh, okay. We have Suzanne Gildert. She's the co-founder and CTO of Sanctuary AI. Soroush Karimzadeh, CEO of Novarc Technologies. Peter Mankowski, the VP of Computer Vision and AI at 4AG Robotics. And Eric Jackson, the president of Cellula Robotics. And then we have as our, oh no, where did I go? There it is. Went the wrong way. And then we have Taylor Cooper. He's the CEO of MistyWest, also Steve's dad. If Taylor, you want to put your hand up and just wave quickly? He'll be moderating our discussion tonight. And tonight's schedule is panel discussion until around 7:30. At 7:30, I would like to open it up to a live Q&A. 8 o'clock, very quick announcements, less than 15 minutes. And then from there onwards, we'll be doing networking and mingling. And I think that is it. So Taylor, I will hand my mic over to you, if that's okay. And I think
Hi, everyone. I might stand, or I could just be like shorter than everyone else. I don't know. I think it'll be easier just to see me if I stand. Oh, I see the videographer is telling me to stand. So, hi, everyone. Thank you so much for being here. It's been amazing to see how these events have blossomed. A huge thank you to Madison and to all of our sponsors who are helping put these together, and I hope you find them valuable. We've got an amazing panel here today. There's actually a ton of expertise in the room standing next to me, and it should be really interesting to hear what they have to say. So maybe rather than me try to read bios, which I will probably butcher, I'll just pass the mic down and you guys could say one or two things, one or two highlights so that people kind of know what your background is, and that might help them later if they have questions.
Sounds good. 1 minute or two seconds? All right. So actually, my name is Soroush. I'm CEO and co-founder of Novarc Technologies. My background originally is in industrial automation, electrical engineering specifically, with focus in industrial automation and control theory. I tried to be an investment banker one day. That was a bad idea. But I became an entrepreneur and I really enjoyed it. So I'll pass it on.
Hi, I'm Suzanne Gildert. I'm one of the founders and CTO of Sanctuary AI. We build humanoid general-purpose robots to run AGI software with the hope that one day they will be very similar to us, living amongst us, being treated just like people are, as fellow beings. I'm actually originally a quantum physicist. That's how I ended up in Canada, because I work for D-Wave Systems, which is one of the only companies in the world commercializing quantum. And then I got interested in AI as quantum processors were being applied to AI applications. And actually, one interesting thing is I'm actually now getting back interested in quantum, because it turns out that people think quantum might actually be really useful for robot consciousness and things like that. So quantum, robots, AI, any questions about that, please ask.
I'm Eric Jackson. My company's Cellula Robotics. I founded it over 20 years ago, but I have to say over 40 years experience in robotics development, primarily in the subsea area, but also in mining. We did a bunch of work for the Canadian Space Agency in the 90s on autonomous robots, and built a couple of autonomous gas stations for Shell in the 90s as well. And in the 2010s, sort of doing a lot of work with subsea mining companies or interested in how you might liberate ore from the seafloor and send it to the surface. From there, we got into seafloor drills, like robotic seafloor geotechnical drills, and then back into autonomous underwater vehicles. And I was just thinking, it was 40 years ago that we did the ARCS vehicle, which is, we call it autonomous remotely controlled submersible. And so it was an autonomous underwater vehicle that did autonomous navigation and obstacle avoidance in Indian Arm. Anyway, they keep dragging me back into it. I've just hired a CEO in the past little while, so I get to be an engineer and project guy again.
My name is Mankowski. I work for Forge. We build robots for mushroom farmers. And those are AI-driven, humanoid-like, basically having personalities and diverse set of skills to address growing mushrooms, taking care of them, harvesting and loading them on a truck.
Awesome. And I guess for myself, Taylor Cooper, I guess I've been working in product development for a while, maybe like 20 years. Half of that spent at MistyWest. I'm an engineering physicist by training, but my superpower would be that I'm very interested in learning a lot of different things, if there is such a thing as a superpower. Anyway, I've got my phone out not because I'm texting people, but because this is my notes for the questions. So, just a quick preamble, I think, and then we've got a couple of questions, and we'll see how it goes. Hopefully, we can get to everything. I think one thing we may all be noticing, certainly in the AI space, but I think generally, innovation is kind of accelerating in the world. If you've ever seen one of those graphs with S-curves for technology adoption, you may see like early adopters, and it's kind of slow, and then the mainstream adopters, which is most of the curve, suddenly everybody gets on board. And then there's the late adopters, and things kind of taper out. If you look at like the adoption of electricity or the telephone, that was a process that really took like 60, 70, 80 years. If you look at Netflix, it took, I think, something like 3 years for them to get their first 1 million customers. I think it took OpenAI like 5 days to get their first 1 million customers, just to give you a sense of like how innovation is accelerating. And I think that's also incredibly true in the robotics space, and we're seeing a lot of that right now. We're seeing, there are some pretty amazing videos out, and I think there maybe is a shout out for Sanctuary. I mean, congratulations, that was huge being part of the GTC, standing right behind Jensen and P.Eng, which is like, yeah, ominously. Yeah. Just like slowly sneaking up. But that's like a huge milestone, so congratulations. And we're also seeing, I think, huge advancements on the manufacturing robotics side. I mean, we have Novarc here, and we have 4AG, but that space is growing rapidly. There are more and more factories that are lights out, hands off facilities, just doing more and more complex procedures. And we're also seeing tons of advancements in the submersible space as well. There's talk of underwater mining, which might bring together two things you've worked on in the, what is it called? Spacing on names here. But the Clarion-Clipperton fracture zone, which is like an area in the South Pacific Ocean. It's something we actually talked about in the last Harvard. About the size of, really? Yeah. It's, okay. Littered with little nodules. So I think the traditional mining approach, which I think is what they're looking at right now, is like, how do we just vacuum these all up? And that'll probably disrupt the seabed massively. But there are other companies right now who are working on robotic solutions that are a little more intelligent and will like actually pick up just the nodules themselves. But that is like the example of where some of these things are going. I think today we'll hopefully touch on a few of these things, a little bit on, where did we think we were going to be 10 years ago, and where do we think we're going, but also where are we now? So the first question I wanted to start us off with is, what advances in robotics surprised you in the last 10 years? Was there anything that moved like obviously faster or obviously slower than you were expecting? I mean, it's a bit of a difficult question because you have to throw yourself back 10 years, but just try to think of what was surprising in the space of robotics for you. Does anyone want to start off or have an idea?
To me, like I've been watching Boston Dynamics since about 1985, where they were having like a pogo stick, and then they started in two-legged things. And so anyway, the demos that they're doing right now are really amazing. And it's not just from the control point of view, but how do they get that much power and torque out of their actuators and power delivery to the environment? So that's super impressive because I've looked at a lot of actuators and worked with a lot of actuators. And then there's a famous book called The Slow Pace of Fast Change. And the subsea industry, like where we are, is still kind of moving quite slow. And I think probably because it's difficult and expensive.
I think what really surprised me has been very, very recent, actually. So at Sanctuary, we've been trying to do humanoid robots, and even before Sanctuary for, I don't know, close to 10 years now. And up until, I guess, 6 months ago, it was considered ridiculous and completely science fiction, and this will never happen. Why are you working on that? And then it literally flipped overnight when it suddenly became a thing. It became a category. It became something everyone was talking about. So I guess it even surprised me. Like I thought at some point this would happen, but I didn't think it would be as rapid as it has been. And I guess for anyone out there that's working on a technology that people are saying is never going to be a thing, or it's pointless. Like, why would you do that? That's really stupid. I think just kind of keep that in mind. Is like it very much surprised me that changed overnight.
From the hardware perspective, I want you to consider something quite extraordinary. New technologies and new trends are usually born out of absolute chaos, confusion, and dysfunctional startups, and then few of them emerge as leaders. This is not the case. NVIDIA killed everybody. There is nobody left. And then NVIDIA Jetson, we are with Orin and Xavier, is childishly simple. No offense, I'm a software developer. But I can take lots of people from the street, and if they are willing to do it, within 5 days, they will have that API up and running. It's childishly simple. That's why our progress is so rapid, because we are all becoming I don't want to say enslaved, but dependent on NVIDIA. And that's why we make rapid progress that we have never seen in the history of humanity, because there's only one choice. You're either with NVIDIA or you're unemployed.
All right.
Do we need to give a disclaimer on this is not financial advice, something. Yeah. You probably know.
I second that. So that's wise. So in addition to all the trends that I think was mentioned, for us, Novarc builds welding automation solutions, so it's really technology that's being used today and has to create value. And when we started the company in 2014, cobots was not a thing still, and cobots in welding was definitely not a thing, because when we dubbed it the first welding cobot in 2017, everybody was asking me, what is a cobot? And when we go to FabTech, we're going to show this. People are going to think that was a spelling error. So we literally spelled it out as collaborative robot. And then last year, when we went to FabTech, which is our largest trade show in our industry, there was cobots everywhere in every booth. So to me, that was a surprising trend. We kind of created a category in itself, which tells you the same trend towards automation. I think it has also tie into the shortage of skilled labor that we're experiencing. Like, all these trends are supported by that. I would say the other surprising trend was the financing trend towards robotics. Between 2014 and 2020, almost, raising funds for a robotic company. Anything that touched hardware was extremely difficult. And then when COVID happened and people realized that the shortage of people or skilled labor is actually very acute, then suddenly, we saw the flood of money being open to hardware businesses. It's still not quite SaaS, but compared to 2014 to 2020 when I was part of it, it's night and day.
Yeah. Really great insights. Thanks for sharing. And yeah, we've noticed a similar uptick in interest in hardware. Who knows? Maybe when people realize that Facebook can't find another 7 billion people to sell Facebook to, they'll be like, oh, maybe this valuation doesn't make sense. Yeah. Oh yeah. Now exactly. So then we can switch over to trillion-dollar cobots, robots. I actually had cobots in the preamble, and I took it out because I wasn't sure if everyone would know what a cobot was. So. My bad, I guess. I guess the next question I wanted to ask, as I have 2 small kids at home, and when I'm not working, I spend a lot of my time folding laundry and doing dishes. That has been on the radar of robotics for a while now. It's when are we going to have the robot that folds laundry or things like that? I guess so. That's the question. Maybe is that something that is in the cards in the near future, or is that still crazy? And maybe Suzanne, you would have something to say.
So I have a fun little story about this, because when I used to go to conferences and talk about advanced robotics, and I was thinking robots and AI are going to automate scientific discovery and all this, and they'd be like, well, can it fold my laundry? And I was always like, no, you don't get it. Why is it always about folding the laundry and chopping carrots and all that? But actually, I had a complete shift on this, because what I realized was not only is that what people actually want, it's a much, much, much harder problem than it sounds, right? So if you try and put a robot in a domestic environment, okay, folding clothes, that sounds pretty easy. Not only is that hard, it has to know the environment. It has to navigate unknown terrain with obstacles that are always changing. It has to interact with people. It has to understand people and have empathy and all these kind of things. So something as simple as doing your household chores is actually one of the hardest problems you could ever tackle in AGI. So I think it's going to be probably one of the last things to get automated, just not because of the complexity of the task, but because of the environment that it has to happen in, and all those other social skills that robot's going to need for that to be safe, for it to do that. So I think it's possible. I think it's going to happen within 5 to 10 years for sure, but I do think it's going to be one of the hardest and last things that we'll see happening. Yeah. Anyone have any other thoughts?
So I just want to support Suzanne's point that I think that if you look back at the history of robotics, the first application of robots was in industrial applications, and specifically welding. But that type of applications we're talking about are dull, dirty, dangerous. We call them NDR. So 4Ds would be the prime, applications where disruption would happen. Usually it's manufacturing, where it's a controlled environment. There's defined safety regulations for it that manufacturers have to follow, and then it would start from there. Also, unit economics also is more supportive of the higher base cost of manufacturing, and then you get to scale. You can reduce your cost per robot or cobot or humanoid, and then you can tackle the more complicated applications.
Oh, there's.
We'll see. Yeah, I'll save myself some passing. Go ahead.
So the finance world probably is changing now to where people can say, yeah, there is a market for that. It's not like going to be $1 million per robot to get something that can be used to do household chores. And I think the other thing is that I'm pretty good with homogeneous materials like metals, but fabric I find very difficult to deal with. So I find it difficult to fold clothes properly. And ironing, forget it.
I didn't realize how bad I was at it until I got married.
I want to be a little bit Kantarian here. So if you look at the marketing videos, for example, recently from, I think it was Tesla's, you would see that the robot is folding. So it's an interesting twist that, there's so many now humanoids coming to the market, like how they're going to compete in what segments. It's a big market, don't get me wrong, but some of them might try to go for the more difficult tasks.
All right, well, 5 to 10 years. I will keep that in mind. I might hold you to that. But actually, your point about it being difficult, I think, speaks to kind of like almost like a challenge that is innate in how people see the world. There's a very anthropomorphic viewpoint that we have, where things that are simple computationally or really complicated computationally we find trivial. And then the reverse is also true. Like physics is a very complicated subject, but from the perspective of a computer, it's like it's the one we understand best. It's the easiest one to do calculations on. Anyway. Yeah, I guess so. Thinking more in the near term, there's a lot of companies right now trying to adopt robotics in a lot of different places. What do you think some of the biggest challenges are likely to be in even like the next 3 to 5 years, or things that are going to slow down adoption of robotics? Peter, maybe you want to. Yeah. Yeah.
Okay, back in business. Sorry about this. The biggest challenge now, to me, is the fact that robotics, they lack personalities. They are very monolithic, delivering tasks. This is about to change. You have more than one. My example is agriculture, mushroom farming. Those robots, they're supposed to have a human-like personality. Some of them accepts the role of a leader. The other one is rather conservative in decisions. The other one more opportunistic. They're supposed to function almost like a small family unit or co-workers. That is lacking today, but is changing very quickly. Think about the consequences of all of them not only be aware of others, but having not adversarial, but complementary set of skills, just like we would pick 10 of us in a room. We are not monolithic by default, we are very different. And robotic is becoming just like that.
Okay. Yeah, you mentioned anthropomorphic. And so there's been a lot of talk about anthropomorphic robots, and Susan's company has done some amazing, absolutely amazing things in this area. But in my experience, most robots that actually have a value proposition aren't anthropomorphic. They're designed to do a task. They look nothing like a human. And there might be some more discussion about this afterwards, but the value proposition for these things is to do things that haven't been done before. Like, it's not just replacing a human in a dull, dirty, dangerous thing, but how do you go and maneuver something that weighs 15 tons and place it at 3,000 meters on the seafloor? A human can't do that. And so you design bespoke solutions to do these type of things. And that's why we have, like it or not, huge industries like offshore oil and gas, and probably like it more, but offshore wind farms, where we're just doing these big, massive civil engineering projects that are highly dependent on robotics. And these are all have to be funded, and new use cases conceived of, developed and proven.
So there's an element of like having, to Peter's point about having kind of a more human personality and interface, and then there's a point here of like that you're making, Eric, about a lot of these robotic systems need to be designed for very specific applications, and so that takes time. It's kind of like IoT, where everyone was like, oh, IoT, everything's going to get connected, and then we're like, wait a second, actually, that's not easy.
We are not arguing here. We are in
I'm
total agreement. It all depends on your vertical, your application, and
Yeah.
what problem are you facing? What is the desired outcome? And what does this mean? Are you going after efficiency? Are you working to discover a new way of completing certain tasks? Or you'd like to do this task better than others in a novel way? So both train of thoughts are actually correct, and they are not adversarial to each other. It depends on what problem are you after.
So the question was about what blocks kind of the adoption or the kind of progress of robots. So I'm going to talk specifically about humanoids and human purpose humanoids, because that's kind of what I know, but I do agree with the points that were made here as well. I think for that particular niche, the big blocker is going to be people's opinion of these systems when they start going out there in the world. So it's one thing to watch a video online of a robot doing something, but when they start walking down the street, I just don't think people are ready for this at all.
We didn't do great with the scooters.
Right. yeah, I know. And
I would feel very worried for the robot, if I'm honest.
yeah. So I think that something needs to be, it's not just about creating great technology that can function really well and be safe. And I think it's also about the social impact, the how people perceive these systems, how people interact with them, and how they are introduced into the world. Yeah. So I think it's going to be more of a social block than a technology or a business or a supply chain block.
So adding to the notes, so Novarc is a little different, that we are in tens of millions of dollars of revenue, and so it's a commercialized technology. We have a great product market fit. So for us, customers really need this technology. So the answer is a little different. It's more on the commercial side of things. The biggest factor in the adoption for us is the status quo. Customers don't necessarily want to leave what they've been doing. That would be followed by the fact that some customers, they have other priorities. They might have to install an ERP, for example, first, or they might have to buy their first cutting equipment before they invest in their welding cobot. So those are the kind of barriers we see in adoption. But in terms of the demand and the long-term trend, it's all there. So it basically delays the adoption. It doesn't stop the adoption.
Yeah, the economics of it is going to push it forward regardless. So you're at like a more advanced stage, I think, relative to some of these other industries. I guess one last point on this: nobody mentioned self-driving cars, and what is stopping that? Because we were supposed to have self-driving cars like a while ago now. Another thing that would be great, though we do have Lyft, which is like pretty okay. That's how I got here. So I guess I've heard different examples for why we don't have self-driving cars, but some of them that I'm aware of are, I think, even though deep learning right now is really amazing, it's not that flexible, and it's not that hard to imagine edge cases that just like are very far outside the training data, and suddenly you have a problem. Do you see that being? Does anyone? I don't know if anyone wants to comment on this. I don't know that any of you have necessarily a background in autonomous driving, but maybe Eric, you have some experience in slightly bigger volumes for navigation.
Well, first of all, I'm glad you said self-driving as opposed to autonomous, because what would be the use of an autonomous car? You tell it to pick you up at some time, and it decides to do something different because it's autonomous. Like autonomy is the inverse of supervision. So something that requires less supervision to do a task is more autonomous than another system that needs more supervision to do that task. So can you have a car that doesn't require any supervision? Well, it's a very difficult problem, like on the open road, on the prairies maybe, on a back road, not too much trouble, but in traffic with people walking in front of you, lights changing, buses trying to cut you off, et cetera, et cetera. It's a difficult problem.
Yep.
And there's tons of different technologies that can be used and integrated to address the problem, but I think it's almost a trigger word for me, deep learning, because people say, oh, AI, you mean deep learning? I say, well, you mean neural nets, because that's one way of solving a problem. But there are tons of artificial intelligence techniques and engineering disciplines that can be integrated to put this all together. And I think it is going to happen, but some people are being a bit religious about it. No, we're going to do it all with cameras and deep learning. We're not going to use LiDARs and blah, 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 blah. So whatever. I could rant.
Hopefully, hopefully it doesn't end up like fusion, where it's always 30 years in the future. But we'll see about that, though. Maybe next hardware meetup on fusion. Anyone? Takers? Okay, so moving forward a little bit, I wanted to touch briefly on AI. Some people might be aware. I think one of the more common models, but like there's a lot going on in the space. Obviously, I already mentioned ChatGPT earlier, and you may be familiar with large language models or transformer models. Earlier, I think this would be back, maybe it was in 2022. Suzanne probably knows the exact dates, but Google demonstrated something that they called a robotic transformer, and there have been a few other companies kind of going down that path now. I was kind of curious if any of you think that modern advancements in artificial intelligence are going to show up or shove their way into robotics, or maybe they already are. Obviously, Suzanne, maybe you'd have some things to say on that. But
yeah, I think they already are. So, I mean, even at Sanctuary, we're using some of these, they're called large behavior models. So it's essentially applying the same technology used in a large language model to robot action. So you're using data from human teleoperation as your input data, and then you're just trying to predict like what's the next step in that data that the robot would take as an action in its motor system. So it's very similar to large language models. It works, but what we don't know is, does it scale to the general case? So with a large language model, we know that it kind of scales and generalizes a little bit because GPT can talk about almost anything. We don't yet know if that works for robot action. So there's some promising results there, but it's not really known yet.
So there is like an element of self-driving cars in there potentially, or?
Yeah, I mean, the neural net techniques that are being used now in humanoids are pretty much identical to these self-driving end-to-end deep learning models. Now, it doesn't mean they're going to work, though.
Yeah. So I guess the question might be then is, when do we think we're going to have algorithms that can generalize beyond their training data? Any thoughts on that, or? I obviously, it's a bit of that's a harsh question.
Go ahead.
But
I mean, no one really knows. That's why we need to do the experiments. Like even the Google RTX showed a little bit of generalization outside of distribution, but it wasn't like. So there are different forms of generalization.
yeah.
So even something as simple as if you want a robot to like pick and place a block, and then you change where the block is by a few millimeters, that's generalization.
Yeah,
if your model's now able to handle that, or if you change the lighting or something. But what people normally mean is kind of like generalized to doing anything now.
Yeah.
So it's sort of it's like the envelope's slowly moving forward over time. More and more generality. Will transformers get to full AGI? I don't know. My bet is probably not, although someone will probably prove me wrong.
It seems a bit like a system 1 with no system 2. Or I don't know. Anyway, separate conversation.
I just looked up that reference that you sent on the Google robot what's it called, RTA?
Yeah, RT
yeah.
or RT2
Yeah, it's
now?
quite interesting. And then we went from there to like chain of thought. So that seems like a potential generalization method. One thing I'm really interested in is using some of the concepts that people in human factors discuss. And there's a school in human factors called ecological human factors, and they're not talking about the environment, they're talking about the environment of the machine that you're talking to, like how it works and how it interacts with its environment. And then there's the idea of affordances. And so the robot can do certain things, so they can afford you different things, and there's different things in the workspace of the robot that maybe it can grab this and it can use that to hammer on something else. And so I think this is where the next level programming is going to be, is to try and teach robots about the affordances that they have and the affordances of the environment. And then once that construct is in place, then they can start to reason about, well, what can I do with this? Can I use this to block something? And then, of course, it's going to get a lot more interesting when we're talking about swarms.
Oh, yeah.
Anyway.
Did you have anything you wanted to add, or no? Okay.
About the system 1, system 2 thing. So it kind of looks at the moment like a big system 1, but it's not clear whether the neural net, if it gets big enough, can't also learn system 2. So I don't know if everyone's familiar with that terminology. It's basically like kind of like motor and instinctive and movement behavior versus like logic, reasoning, thinking through things is system 1 and system 2.
It's popularized by Daniel Kahneman. He's in
Thinking Fast and Slow.
Thinking Fast and Slow. Great book. Would highly recommend. Anyway, come bug us later or someone if you want to know more about it. I guess, so stepping back from kind of software and things like that for a sec, I guess on the hardware side, a lot of companies right now are kind of building their own hardware, I would say. Eric, you kind of touched on this a bit. Soroush, I'm sure you know a lot about it. Are there any areas in the hardware space that you see as advancing rapidly, or where there are large opportunities that aren't currently being addressed? One that I've seen quite a bit of interest in lately is like tactile sensors. But I think there's a lot happening there. And obviously it's the space we work in, so a bunch more I could say. But Soroush, do you have anything you want to... I don't mean to throw you on the spot, but...
Oh, that's good. I guess the interesting trend to me is how fast it's being commoditized. So maybe it's the opposite of what you're saying. I mean, when I look at humanoids costs, I saw one video, somebody made it out of garage for $8K, like do it yourself. So that tells me, I mean, the actuation cost, unless you're doing hydraulic actuation, which Suzanne is going to talk more about today. But if you're looking at servo motor and servo control and traditional gearboxes that are typical in industry, there's so many manufacturers today, because there's an installed base of robots that, for example, the top 4 robotic companies are industrial robotic companies are servicing, and they're manufacturing for it. So the supply chain is there, and for the most part, it's very much commoditized, I would say. But of course, there's research. The research on grippers have been going on for so long, and there are companies and startups that are trying to come up with accessories to industrial robots and cobots. So that's a growing field, but I would, I don't see any big differences in the last 5 years, other than like what I'm following on the battle between the electrical actuation and humanoids and the hydraulic ones. Suzanne, you want to talk more about that?
Well, electrical's definitely becoming more commoditized, like you said. Like, I think the main thing that's happened over the last 5 years, maybe 5 to 10 years, is just people are starting to put actuators into humanoids, so that's how driving everything has just become a thing, right? So now people are finding ways to make them more efficient, make them cheaper, and it's just kind of the regular old kind of commoditization. I think with the hydraulic stuff, that could happen, but I think what needs to be demonstrated first is that it's way superior in several dimensions, and that it is kind of robust and reliable in prototype phase, and then I think people start adopting it and improving it and stuff like that. I think the biggest missing thing at the moment, though, is haptics, and not just on the fingers, but I think you need haptic sensors over the whole body of a robot. If you think about what people do when they're interacting with the environment, they use our whole body the whole time, like even just sitting in a chair, right? How do you know you're sitting in a chair? It's mostly because you can feel your body interacting with the chair. And so I think we need to really start moving towards haptic sensors all over a robot, and that's a great hardware challenge, because you're essentially then wiring up an entire nervous system that has to be almost as good as human skin, and it's just such an amazing challenge. And we're so far behind on that particular sensory modality than we are in, say, vision or proprioception or actuation, even like audition and things.
So putting cameras on the elbows, probably not good enough.
Yeah. Well, that's interesting, because it's actually fascinating is how human-like do you want your robot to be? Do you want it to sense the environment like a person, or do you just want to add cameras and sensors wherever you want? And yeah, exactly. So it depends how you're designing it. Like, we try and design it to be as human-like as possible, because otherwise the bar starts moving and you end up it keeps changing and changing and changing if you're trying to build a general robot, so there's not really everything you can design it for. So in my experience, you just end up with something totally random that goes down a weird rabbit hole and then gets stuck. Yeah. Now, I totally agree, if you're designing it for a specific application, then there's obviously a best design for it. So, yeah.
Just one thing that I see is that, like, sensors and actuators are pretty much all intelligent now. It's not like you just buy something that's analog and you put it into your A to D converter or your 4 to 20 milliamp converter or something. There is a problem with that, because so many of those interfaces are crap, and they're slow and they hang and blah, 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 blah. But I kind of wonder if it's going to be like personal computers, because back when they first started, there were you'd get a whole personal computer from somebody, but now, like, all the components of a PC, like the keyboard and mouse, the disk drives, etc., the monitors are all standard, and they can all talk to each other. You can unplug one and buy somebody else's better one and plug them in. So I think that's a trend.
Yeah, so it commodification on that front. Yeah, and to Soroush's point, I think. Yeah.
Yes, I I totally agree with this. I'm going to give you probably a relevant example. I work for the company that grows mushrooms, and imagine what the robot and the actuator have to do to successfully grab the mushroom, lift it up without leaving the mark. Your mushrooms that you buy have no marks, they have no damage. So this requires human-like touch. The suction cup required us to think about sensing that it's not commercially available. Our robot has a sense of touch. It knows the difference between how the texture and the resistance of the mushroom feels like for every part of the mushroom itself. My background is neurology. I spent quite a bit of time studying human brain. It's the same thing, right? For remote operations, the robot's supposed to sense and be aware of tension, texture, and make lots of decisions. We don't do this for medical field. We do this for mushrooms for a single purpose. When you get those mushrooms, they have to lack bruising, and this creates dilemma. Until now, there's no commercially available solution and gives me actuator or some kind of a suction cup that has the sensing and the haptic feedback built in. That's where the technology is lacking. I agree with you.
Okay, great. I had 2 more topics I wanted to cover, and then we can open up to some questions. And I think maybe I'll reverse the order of the questions a bit here. But I think, so we've talked about a lot of really interesting technology. One of the challenges to innovation and bringing new technology to the world is who's going to pay for it. And that is definitely a challenge in Canada, I think, especially relative to the US. So I kind of wanted to open things up, and Peter, I know you had a thing or two to say about this because you spent a lot of time launching companies in the Bay Area, and Suzanne, I know you also have some experience doing this, and you've also exited Kindred, so I'm sure you've seen a few things, and Soroush too. So, you know, what are your thoughts about kind of the differences in the Canadian ecosystem when it comes to funding innovation versus the American ecosystem, and is there anything we can learn there, or what could we do better?
Are you sure? Yes. So I had 3 startups in Silicon Valley. First 2 were horrible disappointments. It was awful because I tried to run it the Canadian style, and this just doesn't work for investors.
What is the Canadian style? What is like the top 2 or 3
So now,
places?
not to create a riot. I want to make friends, and obviously I wasn't born here, so I look at Canadian society slightly different. Canadian style that works for Canada, it's long-term vision of breaking profit and being rather conservative in expectations of, I'm not going to lose your money. Your pitch is, I'm going to do whatever is possible, not to invent something of relevance, but I will triple your money, and I'm not going to lose it. It's this very bank-like approach to it, and Canadian market expects that. I'm going to bring profit in 3 years, show me your Excel spreadsheet. Yeah, I'm going to give you $100 million, good to go. Silicon Valley, it's different. My last startup was successful. We had a successful exit because our investors said, fail fast. I'm going to shower you with lots of resources. I want you to be a wood stove. Burn the money as quickly as possible. I want nothing left in 8 months, but I want you to accomplish something with it. Because I have 20 other investments, and I don't want this to linger in my bank account. Most likely, you will be fired very soon, but I want to fire you as quickly as possible. Yeah.
I think I would echo a lot of what you just said as a similar experience. I think there doesn't seem to be quite the appetite here for what I would call moonshot deep tech investments that are very risky. So a lot of the culture in the Bay Area is more like take a lot of risk, go for things that seem improbable, that could be 10, 20 years out, like let's invest in them today. Whereas, you know, the Canadian ways is much more, you know, like how are you going to make this profitable tomorrow kind of thing. And another thing I would say is you can get trapped a little bit because I think it's not that difficult to raise money for a seed, maybe pre-seed, seed, and maybe going into Series A here. So you get this false sense of, oh, you know, they're backing this kind of really cool deep tech technology, but then when you get beyond that, it gets hard. Yep. So you kind of hit this wall at that stage. So you're given this sort of sense of hope at the seed stage that, ooh, people are interested in my crazy deep tech idea, and then it just sort of like the funding dries up after that.
Yeah. Is there anyone from BDC here? Oh, okay, I have an example to share about BDC. One of our partners, one of our customers, was talking about negotiating with them, and they wanted a valuation that was significantly higher than what BDC was willing to talk about. And their exit scenarios didn't include like a unicorn outcome. Like it just wasn't in the cards as something, they hadn't seen it, so to them unicorns don't exist. But I guess when you go to the Bay Area, the idea that unicorns exist is there. So there is that possibility to really swing for the fences. Whereas up here, like it's harder to raise that money, I think, because you can't point to this larger valuation on some level.
I think one other thing that happens is that because companies often have difficulty raising in these sort of like middle rounds, they start bringing in big US investors at that point. And then you sort of organically end up spinning up an office there.
Yeah.
And then before you know it, your HQ is in Silicon Valley. Before you know it, you're exiting. You're being bought by a British grocery firm. This is what happens to Kindred. You invest. The first investors were all US. The second set were like Tencent, like Chinese, and then it was bought by a British firm. So it's like, where's the Canada story here? And I think a lot of that happens. A lot of companies, they don't want to exit Canada, but they just sort of organically force down that route.
Okay, so we need to burn the cash faster so we can keep companies here. Just anybody who's got a startup, just keep that in mind.
Well,
if
maybe
you need help, if you need help
them
burning
to stay
cash,
here as well.
come talk to us.
Yeah. Incentivize companies to stay here.
Yeah. No, I mean, that's kind of that's like a thing that's in the back of my head too, is like, how do we build a really amazing, a world-class ecosystem of innovation in where we are? And that's kind of what these meetups are about.
So I'll just be, what's the word? The other side. So we've been totally bootstrapped and sold off 6% of the company in 2022. So that's our story. But a related one is that we're partnered with another startup out of Houston, Texas. And we submitted a proposal, actually it was a pre-proposal to the BC supercluster, and we said, well, there's a business out there, it's like $200 million in 3 years. And they said, no, it's too small for us.
So to finish on this topic, you can look my bio up. Several years ago, I discovered how to build a fabric that was meant to be used to build female bra to look at breast cancer as she was wearing it without mammogram. Nobody in Canada would agree to help us financially because A, it was too ambitious, too good to be true, plus we will be going against well-established mammograms. Nobody would talk to us. I went to US, to Dover. I found a group of investors, and they started laughing, and then two of them stopped laughing, saying, my mom died of breast cancer. I'm going to give you the money. I'm going to connect you in 6 months if you do this and give me the fabric that can be placed on any patients, and if we can actually determine this, you will stop, and I'm gonna flip you over to actual large VCs. We did this in 4 months. I came back to the office. My office is empty. I asked around what happened, and we were sold to others. My service was no longer required. The company grew to a very large corporation. That's how they operate. They have charisma, they have courage, and they are very opportunistic. And I did all what I did. I built a piece of fabric that was actually sensing breast cancer on human, and that was enough to actually company to grow, and they went over 9 rounds of financing. They are going public soon. So that is the difference, is the appetite to accomplish something extraordinary, borderline utopian. The name of the company was Celestia Health.
Soroush, anything you want to add?
Well, maybe just a show of hands of how many of you guys are raising funds today, these days. All right, so I see a few hands up. So yeah, Canadian ecosystem is conservative. Are the investors conservative, causing entrepreneurs to become conservative, or the other way around? I think for the entrepreneurs and CEOs or CTOs or CFOs who are raising funds, you have a strategic choice. So you can raise from the Canadian ecosystem, or you can just cross the border and raise funding in the US. The good news, I'm going to focus on some of the good news there, is that I think Canadian tech ecosystem is on the radar of the US investors. They have had success with their previous investments, so there's definitely good stories that you can bring to the table to convince your investors. The second point about funding, I know you mentioned, I think your intention was private funding, but I want to point out that Canadian ecosystem, one of the things that got going for it is the support of the Canadian government. I know there's some people here who work for the Canadian government, so I definitely would say that, and there were some points that made, like, there are definitely programs that are not great, and some of them have failed. So that's all true, but compared to US, for example, there's a lot more support from the government for companies, especially like in the seed and pre-seed and even up to Series A. We have great programs. I'm a big fan of IRAP. There's SHRED program that's also very positive. I think these things are what you'll be getting if you're staying in Canada. And there's another choice you can make. You can also move to US. So when you're raising money, you want to think about these strategic choices before you commit yourself down one or the other path.
Yeah, great points. I think we didn't mention like IRAP or SHRED or any of that stuff, but there's lots of things to help people get companies off the ground here. And I know in the US, I advise in CDL as well, and there are US companies in CDL. They struggle in those early stages to get funding. It'll be like they're trying to sign a contract with the US Air Force or the US Navy or something related, or DARPA, and it can just take a really long time to get that signed, whereas for us, we're like actually a lot faster, I think, with SHRED and IRA. So there's some really good points there. And also the point about, well, why don't we just bring US money here? Is a good one. Okay, so last topic. I know we're a little bit over time, but I saved hopefully the best for last. I think this is the third time we've hosted welcoming our robotic overlords, I think now. That's a little tongue-in-cheek, but I think there is kind of an increasingly relevant subtone there. So I wanted to open things up and just kind of ask, are there any ethical or maybe more societal level impacts that you see? Are there either yeah, sorry Peter has things to say. And I think related to that, societal impacts for humans, but I think you could really stretch that if you want. You could say maybe we're going to be sharing the planet in the not too distant future with consciousnesses that are not necessarily organic. So anything you want to say about that?
I'm not sure whether I'm barking at the right tree. Stop me if that's not the direction you want this discussion to go toward too. Imagine robots, they will fold your laundry and they will do 90% of your daily tasks. How on earth are you going to fill the time with something positive and relevant? I'm not going to say my brain, it's wired to develop bad habits. That's how humans are wired. When you have excessive amount of time, regretfully, I'm that person. I only develop bad habits. I don't develop good habits. Maybe you are different. I hope you are. So those robots, with basically allowing you unlimited freedom of waking up and asking yourself, what am I going to do now? There's nothing to do. I'm telling you, this will not end well for us.
Idle hands are the devil's playground?
I'm gonna respectfully disagree very strongly.
That's great.
I think that I have hope that people will find things to do. So I do a bunch of random art stuff just for fun as a hobby. And if I had more time, I'd love to do things like learn carpentry, learn how to build, a house. All these things could be done by robots, but they don't have to be. And I think people will learn skills just for the sake of learning them, the joy of going back to doing artisan crafts without having to do things that we are paid for or having to do drudgery work.
I agree with you. I play this card very carefully. think about COVID. Over 2 years, our lifestyle has changed. I was working from home. Most of you were locked down on a number of occasions. For certain demographics, the damage that was done to us, how we are wired, is beyond repair. Our society is very different now. We'll never recover from those 2 years. We are different, and during those 2 years, don't judge, I developed so many bad habits. It will take the rest of my natural life to fight them. That was not a good experience for me. And I'm sure some of you can relate to that.
Oh, yeah, please.
Sure. I think we're going to see this on the internet before we see it in robots. And already so many people live their lives, it seems, attached to their phones that they probably might not even notice a robot walking past. So they'll be interacting with robots on the internet. So.
I want to make a point about the COVID thing, because I think what we're seeing now is almost the exact opposite of that. So I think what happened with COVID is it tore people apart. It tried to isolate people from one another. And I think the way we work and live is doing that to us now. We're becoming more and more isolated. And I think when robots are doing all of the mundane work, I think that as long as we can solve the UBI or whatever it is problem, like how do we actually afford things, I think we'll come back together. I think people will spend more time together with other people when we don't have to, work 80-hour work weeks or whatever. The crazy thing is now people can't even have families anymore because they have to have double income households working all the time, delaying it due to career and things like this. So I'm hopeful that if there is no work anymore, or at least if it's a decision people can make to do things rather than having to do them, I actually think it will be a force to bring people back together.
I hope you're right.
Yeah, me too.
Maybe on the more pragmatic side of things and positive note, I'll give you an example. We have a computer vision package as an add-on for our cobots, and that will create self-welding, not autonomy, capabilities for the cobot. So in one case, we deployed this, and there are many welders that are towards retirement, right? So there was one case, the guy was like 60 years old, and they usually lose their hand skills, but he knew what a good weld is. So the shop we deployed this package to managed to keep that person employed, and he was just monitoring, and even though the solution was working as a full self-welding package, but autonomous package, but they still wanted that person to be there. They kept him employed. That person, the welder, was pretty happy, and I mean that's a positive impact on the industry that we can extend the careers of these senior welders.
That's an awesome example. Thank you for sharing that.
I'm really interested in making robotic systems that do what we tell them to do, and we design them for a job. And so in this space, there's always room for the supervisor. It's always going to say, well, the robot should come back and say, this is what I saw, what do you think I should do? And then you interact with the robot. Maybe they'll even just debate it with the robot, and then it'll go and do what you decide. So that's an area that I'm very interested in. And just to extrapolate, in the world that we live in the subsea, there's no internet and there's no GPS. And so the ability to talk with a machine is very difficult. So it's super low bandwidth. So you always have to think about how am I actually going to talk with this thing, and what kind of a language can we have? So I just find all the stuff is totally interesting, and the less I have to do at work, the more I can work on this stuff that I like.
Good job hiring a CEO. Obviously there's lots to unpack there. I guess, maybe we should open up for questions now, unless anybody else has another point they want to make. I probably have 400 more things I could say, but I'm sure everyone else has questions too.
Hand the mic to,
yeah,
and then I can go around.
So you've been talking about how we might get help with our laundry. How far away do you think we are before the enhancements actually start to become part of us? So you talked about extending someone's skills, but when are we going to be in a room where, like today, all of us have a smartphone in our pocket? We're all going to be somehow robotically enhanced.
Great question. I'm not the person to answer that, though.
I'm kind of interested in where this whole brain-computer interfacing and like Neuralink style technology is going, because that's the way we can really interface with our technology directly. So not only could it control devices in the future, but if we really try and understand how the human brain works, we're actually able to interface with it technologically. We could even kind of connect with robots and maybe experience what they're experiencing. So it's not really an answer to your question, but I'm definitely tracking where that technology is going over the next decade or so.
There were some really interesting papers, I think, this might have been in like mid-2022, where they were using transformer models to analyze the scans from MRI machines and use that to like accurately reconstruct images people were thinking about while they were in an MRI machine. So like there's already early research suggesting some of this stuff is possible. But my guess would be, well, not that I should really be offering a guess, but it'll be like, what's another word? Maybe a bit like your experience with humanoid robots, where like nobody believes it makes any sense to work on this until one day suddenly it's like, oh, why wasn't I doing this yesterday? So it'll probably take us by surprise, would be my guess.
Susan, maybe you correct me if this is misguided, but maybe there's analogy between your question and early days of RIM, BlackBerry. I was an early employee of BlackBerry out of Waterloo, and everybody laughed at us saying, you don't need that. We already know how to go to the post office or call somebody. This is not required. And it was maybe a decade. And there are some striking analogies between this being quirky, utopian, and just for business people and geeks into becoming part of our life. All of you have smartphones. You live your lives very differently. And all of this happened because of Mike Lazaridis having the vision that was a decade long. We got killed by Apple very quickly. BlackBerry is gone now. Different story for different evening, but maybe this answers your questions. I'd like to maybe venture into pure speculation. We are maybe looking at roughly a decade. What do you think?
Like for when we start actually merging? Yeah, I think within 10 years we'll start to see the first. I think it'll still be early days, but I think it'll be more there.
I just want to add, when we think about these technologies, common thing that I see is people think about when that technology would be available as kind of out of a research institute, but to get it to actual like wide adoption, there are many things that can go wrong. So you could miss a decade because of poor, execution. So if you look at like electric vehicles, for example, or even smartphones, people tried and they got pretty close in terms of technology and the product, but it didn't, take off. So you have to think about then, okay, when the technology come out, and then you have to think about what players are going to try to commercialize it, and then it becomes very difficult then to come up with an estimate because there's not going to be too many factors at play. It's not just the technical aspect of it. It's going to be a commercial aspect and how it's going to be manufactured, scaled, supported, what kind of use cases for it. Before it becomes like a smartphone that we use today, up to billions of units deployed.
What sort of legal or ethical challenges do you foresee with the integration of AI and robotics into society, with things such as liability issues and things like that?
Yeah, you go first.
So I can tell you from our perspective, when we introduced our cobot, in terms of safety regulations, the standard for cobots was not out yet. So being part of that creation of safety regulation around cobots really actually was impactful on Novarc, because I mean, we contributed to the change, but also it helped us design the product in a way that it will be adopted by the industry in the end. So I would say in the industrial space, this is a very well understood problem. Also from like ethical perspective, when you look at like security of data and privacy, there are more frameworks. I would say when it comes to B2C and outside of, in the day-to-day lives, there's much less regulations that I see. I mean, there's on the privacy, there is a lot, but on the safety side, I don't see a lot of standards. So it's still to be created, and I think it's being developed.
Yeah, I think it's going to be really, really interesting to see how this rolls out. Because as I mentioned before, I don't think the blocker is going to be technological. I think it's going to be social integration, and kind of comes along with this is the ethics and the safety. So you see this with self-driving is kind of been the problem going forward. I think when you're having any technology that's controlled specifically by neural networks, they could be transformers, deep learning systems, they're kind of black box systems. So you don't know always what they're going to do. And I think that there is a whole kind of area of companion technologies that need to be built around these that allow us to inspect those systems better, maybe make them, create them in a more modular way. I'm a big fan of more modular style cognitive architectures where each piece is a trained neural net, but there's like APIs between them. So you can put like little software oscilloscope probes into the system at different points and see what's going on. You just can't do that with a billion parameter transformer right now. There's not a lot of ways of seeing like what's going on in there and why. So I think this is a huge area, this whole safety and ethics, but I think one way is going to be trying to understand what these networks are doing more, and I think there'll be a lot of technology and a lot of standards developed around that kind of thing going forward.
The two major like high-level applications of robotics in the world that I work in are robotic systems that get data, like survey robots and acquire data, and others that interact with the workspace. So that might be one way of thinking about it. If you're not exactly, if you're just talking about robotics and AI that are involved with data acquisition and data transmission, well, we already have that issue legally and ethically with the internet and the big push for legalizing misinformation, for example.
All right, this is a question maybe geared towards Suzanne, and you're talking about interacting with robots in sort of a really humanoid fashion, and so I have a 5-year-old golden retriever border collie cross, and she knows that when she wants to go for a walk, she go put her paw on my wife's lap and whine, then my wife will tell me to go take her for a walk. Then the anti-example for that is IEEE Spectrum had an article about AI prompt engineering is dead, where they got, I guess, LLMs to optimize with nonsense prompts to get a more reliable and consistent output from the LLMs. So as an engineer, I can see that there's a huge divide between a real genuine interaction with these machines versus sort of what's available to what the public thinks is happening. Like you already answered that kind of, you're talking about a modular approach. Do you have any other comments on how we're going to get from here to there?
Well, I have a kind of far-out philosophical comment if anyone's interested.
Sure, yeah.
I think we're really going to have to understand what consciousness is. This is just my personal view, and it's kind of, I guess it's like my pet favorite subject, so I'll always find a way to slip it into the conversation. But I really do think like what sets us apart from other objects and systems and machines is kind of awareness we have of the world and of ourselves, self-awareness, and then the ability to project that awareness onto others and have this kind of like shared conscious experience. I think we're going to have to put that into machines, into robots, especially, maybe not all robots, but these general purpose ones that are interacting with us on a day-to-day basis in our domestic environments, like we interact with each other. I think they're going to have that. And so I'm kind of interested in that as a sort of side research topic. But I think we're not going to get that kind of genuine responsiveness and that genuine bond with these new systems until we really understand what this kind of crazy thing is that we all experience, but we really don't, science doesn't really have any idea what it is yet.
I thought you were going to use the liability question as a chance to talk about consciousness, but I think that it has a lot of relevance. A really interesting point.
Before the next question, I actually have a question for all of you, and I would appreciate a show of hands. How many of you think that within your lifespan, robots will have legal rights? Yeah. So what does it tell you about which way we are going with that particular initiative? If they have rights, they have responsibilities, they will have conscience. This opens up discussion for another evening. I'm absolutely captivated by rights, not only for humans, but also those, there's not even a name for what's coming. They deserve to have rights. And the fact that there is more than few show of hands is very encouraging. It's more philosophical. Any comments about rights for that?
Well, a lot of people say, why would you do that? And it's kind of this gut reaction, like, oh my goodness, don't give them rights, like don't give them agency. But I want to make one argument as to why it's important, and maybe I could convince some people that don't think it's a good idea. So imagine two scenarios. Imagine a scenario where all these general purpose humanoid robots have some sense of autonomy, and I mean that in the real autonomy sense of the word, some kind of agency. They're allowed and encouraged to make their own decisions, just like we are. They're treated like moral agents, like citizens. That's scenario one. Scenario two, they are mindless automata that do whatever they are programmed to do in a fleet management mode by whatever centralized power is programming them and telling them what to do, which could be open to being hacked by, whatever kind of agency or country you want in here. Which one of those scenarios do you think is safer? Now it's up for debate, but I think the ones where the robots can consider the consequences of their own actions, consider themselves as moral agents, and take their own decision making and then have the consequences of those decisions borne upon themselves. I think that's a much safer world than where they're all being fleet controlled by, oh wait, what was that movie?
I just want to add one slight twist on that, which is, I don't know if anybody follows Cruise, the self-driving car company. They've been in the news for bad reasons more recently, but going back a little further, they were in the news because they had a whole bunch of cars get stuck outside of a concert. They were connected over 5G and getting waypoints sent to them. And because they all clustered in one area, they overloaded the 5G network in that area and couldn't connect, and they all stopped moving. And so even if we're not worried about the deeper metaphysical point, which I think is really interesting and important, there are reasons why you need a degree of independent autonomy in these systems anyway. And then, the last stupid thing I'll say is what if you can't have self-driving without some degree of agency here too, right? Are we gonna give all of our cars citizenship? I guess we'll see. Lots of hands. Mike, you've had your hand up a couple times too.
No, totally opposite kind of a question. When we were talking about enabling technologies and some of the advancements you've seen, none of you mentioned energy systems. And I'm wondering, are lithium-ion batteries good enough, or are you guys going to have to figure out how to put power on these things so you can untether them? And I know there's a different diversion of autonomy, which is tethered or untethered, which is even more rudimentary. But if you're untethered, how are you going to power these things?
We're actually putting hydrogen fuel cells in subsea vehicles, and it makes a lot of sense because the vehicles are made out of metal and they sink, and so you have to add flotation to them. So we have 250 kilowatt hour energy system, and it has 16 kilograms of hydrogen. There's a lot more oxygen as well, but just it provides a lot of buoyancy. Anyways, it's an excellent application for hydrogen. And lithium batteries are a pain in the ass to try and export from point A to point B. Whereas Charlotte in the front row went to Australia with the vehicle, and they just ordered some gas bottles, And so the gas bottle showed up, filled up the vehicle, and did the demo.
It seems like you might be planning a lot of people here might know me as a hydrogen fuel cell development guy. I didn't set you up for that.
That's a loaded question.
We have time for one more question. Okay, one right here.
Mine is a bit nerdy. What's a token in robotics, and what's the largest robotics data set on which you could actually train things?
That's quite a technical question. I mean, I guess the answer to that, to the token question, is no one really knows yet how to tokenize this kind of new multimodal data well. Again, the Google Robotics Transformer paper is probably the one that everyone's sort of using now. So yeah, if anyone's interested in how they did that. But a lot of people are looking into combining different foundation models as well. So tokenization that's worked well for training image models and language models kind of being used, and then those models are being kind of hooked together as well. So I guess the answer to that is no one really knows yet. Largest data set, I don't know. I mean, I would check out, again, the Google paper. At Sanctuary, we've trained on, like, I would say we're looking at data sets between hundreds to thousands of training examples at the moment. Is of that scale. So, but that's for a single simple task, right? So you want to check the way you automate things is test like really simple tasks first to check those work. So that these are obviously prototype tests, and a task would be a few seconds. So you can kind of do the math there. It's like 1 to 2,000 times, I don't know, maybe like 5 to 10 seconds or something. And then that's multiplied by the data bandwidth of the camera plus all the motor modalities and the haptics of the robot. So that gives you kind of an idea of the size of the data set.
Maybe this is only relating to agriculture, to growing mushrooms, my world. I'm a mushroom farmer. So I hope you find this relevant. We discovered not to work on singularity of data set. We have stack and sample with multiple models, and each model is trained on slightly different and augmented data set. So if you think about having 5 models, they have voting rights. Each data set, it's 10,000 images times 6. So that is roughly what the agriculture has to offer today. Having singular model trying to solve multitude of problems doesn't seem to translate well to my small world of agriculture. So it's almost ironic that you will have a super learner and lots of slave models, each of them specializing in certain things. Each of them has 10,000 units to train on. I hope this helps.
Okay, and we'll get the final question.
Thank you. Appreciate that. My question was starting off with one of the comments you made with the S-curve. And so now let's limit it down to just the industrial arm, because topic of today's for the industrial arm itself. With computers being in everyone's home and office, if we're thinking back to the equivalent of, let's say, Xerox that ended up having a specific machine and they leased it and they came and fixed it and all that kind of stuff, what would it take for a warehouse/industry to have in place so that a robot can show up, do its work, and leave? And that way it's centralized on who is managing those bots and repairing them, etc. And I'm effectively renting someone for that period of time. So may it be someone who's coming and doing the janitorial work overnight, because there's nobody else in the facility, it just does it. So now ChatGPT was able to get that much because everyone had a phone in their pocket and were happy to install apps. X number of years ago, if you wanted to get something, you want to watch TV, you got to make sure you had electricity. You got to make sure you had all of these different things for that to work. So what are the main pieces that will enable to be able to have this equivalent of a SaaS model, to be able to have a low input for a small mom and pop shop to have certain things in place so that they can have a robot come in to do certain things, let's call it, without anyone else being there?
Well, there certainly are robotics as a service companies in various applications, subsea especially. But you raise a good point, and there's an explosion of interest and research in the field of business models and how you can map business models and so forth. So there's going to be some very interesting innovations in business models that are brought out by this.
I mean, one limiting case of what you're talking about is absolutely nothing needs to change. So this is the vision of the kind of the full humanoid general purpose robot. It'd be like a temp worker. So it'd kind of be, there'd be an app like an Uber app, but it would be a robot, or like TaskRabbit. So you would just say, I want the robot to do this job for me, and then one would just sort of like turn up at your doorstep, and then all the complementary assets that robot needs to do its work are just all the same things a person would need. So you wouldn't need any additional infrastructure, any additional kind of like things to support that bot. So that's just like one extreme case I wanted to point out, that there is a world in which we don't need to change anything. Now that's kind of a bit more of a mid to long term future. Right, yeah, exactly. I just wanted to make that case that, you know, that is a future we could think about.
Yeah, I actually wanted to ask that same question of Soroush. Like, you're already shipping product that is like, there's pull through, the market wants the robots you're making. When will you get to a point where it's like, here's a couple pieces of metal, weld them together, like I don't have to program this, like figure it out. Do you see that as a thing, or is that still a ways out?
So robot as a service is an interesting model. We have deliberately decided not to pursue it, and we're using a CapEx model. Arguably, it is one of those execution missteps, I would say, kind of paused because of COVID. There was a tide that was rising on robot as a service before COVID. Many of the companies that were using RAS, unfortunately, like went under because people started giving those back. And so now there's very few examples of companies that are using RAS, and arguably this might be a missed decade for RAS. We will see how this is going to unfold. Again, this plays into the investors' sentiment towards the success of previous players. But you're absolutely right in terms of your intuition that that's the direction that ultimately things will go. There would be dominant players in the end that would be able to offer this as a TaskRabbit. But I think the arc of that would be probably, I would guess, 10 to 20 years. Again, it's a very attractive model. From our perspective, in Cobot's world, to answer your question, you would have to justify how it's different from a lease or a rental. So there's the service piece has to be really figured out. So what are you trying to sell that would justify the premium of a robot as a service over just a pure rental? Because you can now rent cobots. You can lease them if you want. But if you're committing to, like, say, $20,000 per month for this fully autonomous scanning the part, welding it, and for 2 years commitment or 3 years commitment, there is a company that's trying to do it today. They're trying to, and I'm hoping they're going to succeed, but it doesn't seem like they're getting traction. So what are you offering? Are you guaranteeing the quality of the weld? Because ultimately you're owning the result of it, right? This is fully autonomous weld. It's a very big liability for a company that's providing technology to be able to underwrite the risk of a weld going wrong when it's doing fully autonomously. So what is that service component? There are also companies, to your point, that are only focused on the business model. So they're literally buying cobots and robots, and it's a pure financial play. They're saying we can offer this cobot on an hourly basis to customers, and they don't have any technological offering into that. It's a pure financial service. And they're still in early days of it, but I think, again, it's unfortunately a missed decade for RAS because of some of the underlying trends that have happened.
Really interesting.
I think that's it. We've gone a little bit over time, but I really want to, if everybody can give a round of applause to our speakers.